Students, welcome back to my channel NJ Math World. Today we are going to discuss about the chapter functions. So what is mean by functions? And it is from computational discrete mathematics of first semester BCA SEP syllabus, and it is also for the students who are from second sem BCA discrete mathematical structures second semester NEP syllabus. So yeah, we have what is mean by function. A function is a concept is which is used throughout the mathematics, and the concept of the function can be drawn from a relation itself. What is mean by function? Function is a nothing but a special type of a relation. Function is a special type of a relation. Okay, and the type of relation is a fundamental in all branches of mathematics. We can see this the use of the function in mathematics discrete mathematics is to define the discrete mathematical structures such as sequence and strings, while in the computer science the functions are used to represent the duration taken by the computer to solve the program of a given size. Then yeah, what will be the definition of function? A proper definition of function. So here it can be written as let A and B be any two non-empty set. Let a relation f from A to B is a function from A to B if and only if for every small a belongs to capital A, there exists a unique element small b belongs to capital B such that a comma b belongs to f. A function from A to B is denoted as f from A to B and is written as f of A belong equals b for all small a belongs to capital A and for all small b belongs to capital B. So what is mean by this? So here it is. Here, if it is the element A, B, C, D, and here we have 1, 2, 3, and 4. See here, this is a set A and this is a set B. So the relation from A to B is called as function f of x. So now, and f of x, this is again we can say this as y is equals to f of x, and this one you can call it as x also. Okay. Then now, what is this called? This is called domain. It's called domain. What is this called? This is called codomain. Then the elements are mapped to A to B. So the elements which are there in codomain are called as image. The elements which are there in domain are called as pre-image. Pre-image. Fine. So this you have to remember so that the definition of one and on two will be easy for you to remember it. Okay. Then moving on the next one we have functions are known as some important points. Functions are known as transformations or maps or mappings. If A has element and B has n elements, their total number of functions from A to B is n to the power of m. Okay. So to find the total number of elements in functions from A to B, we should be using the formula n to the power of m. Then if A has m elements and the total number of functions of the set A will be m to the power of m itself. If there is only one set, it will be m power m. If there are two set, it will be n power m. What will be that? That will be the total number of functions from A to B. Okay. Then we have here for they've given here if A, B, C and if A equals 1 to 3 and B equals AB, the relation is from 1 to A to 2a, 2 comma a and 3 comma b is a function. So how do we represent that in a form of function? So what they've given? So it is a and this is b. The elements of a are 1, 2, 3. The elements of b are a and b. There is a mapping from 1 to a, then a relation a to 2 to a, then a relation 3 to b. Okay, so this is a function from a to b. It's a function from a to b. Okay. Now, how do we write this? This we can write it as f of 1. F of 1. It is mapped to a. Then f of 2 is also mapped to a. Then f of 3 is mapped to b. Now, we have to find whether it is a function. F is a function as every element of A is related to exactly one element of B. So here why it is function? Because every element of A is having one image. If it is having one image, it is called as function. Okay. So yeah, next one you have, the other one is they've given if A is 1, 2, 3 and B is AB, 1 comma A, 1 comma B, 2 comma A, 3 comma B. So yeah, we will take the other one is 1, 2, and 3, and here it is AB. So it is a mapping from 1 to A, then 1 to B, then 2 to A, then 3 to B. 3 to B. Now it will be f of 1 will be A, f of 1 will be B, f of 2 is A, f of 3 is B. So now we can see it has one element of A has two images. Okay, since the element 1 is in domain has set A has two images under F. So how many images we have? We have two images. Is not a function from A to B. Since we have, it should have only one image, then it is a function. Since we have two images, it is not a function of function. Okay, then moving with the next one, we have representation of function. So every element of A has an arrow mark coming out from it. Okay, it should be there. The steps should be followed. No element of A has two arrows out it directed to two different element of B. Okay, so what are the represent? How do we represent a function? All elements of A are originated on one arrow directed towards some elements of B, but it has not necessary that every element of B should have a terminating arrow. So for here they have given some example. So yeah, first one we can see only in first one and first, second, and third we can see only C defined a function. Why only C defines a function? Only C defines a function. In A there is an element A, namely B, that is not sent to any element of B. There is a B which is having no image, therefore it is not a function. Then in second one you can say the element C is a in A is not sent to unique element B. Therefore, two arrows coming out from C, one pointing to 2 and another one points to. So here C is having two images. Therefore, it is not a function. Then third one, you can see A is mapped to 3, C is mapped to 3, B is mapped to 1. So here each element of a domain has only one image. then it is called as function. So here C is a function. Okay, then yeah, next one. Note, function every function is a relation, but every relation need not be function. Okay, a function from A to B, then im- important point of above functions are given below. So what are the important points? Every element of A has a image in B, and if every element of A has two image in B, then the two images cannot be different. Then an element B belongs to capital B need not be a pre-image in A under F. Two different elements of A can have the same image in B under F. A, F, B and F of A equal B are one same. Okay, where A comma B belongs to F. We can write either by A F B, or we can write F of A equals B. Both are same. Okay, the way of representing is different, but they are both same at a time. Then yeah, next one. If G is a function from A to B, G maps from A to B, then F is equals to G if and only if F of A equals G of A for all A belongs to capital A. So here we have two sub functions, A1 and F of A, F of A. Okay, so here you can say that for F from A to B, if A1 is a subset of A and the F of A1 is a denoted by F of A1 equals F of X, where X belongs to A1, then F of A1 will be a subset of F of A. Here F of A is called as image of A1 under F. Then if F of F from A to B, where if B belongs to capital B, and F inverse of B is defined by F inverse of B equals X belongs to A for all F of X equals B, then F inverse of B is a subset of A. Here F inverse of B is called as pre-image of set B under F. Then you have, if F from A to B, if B1 is a subset of B and F inverse of B1 is defined as F inverse of B1 equals X belongs to A, F of X belongs to B, then F inverse B of B1 is a subset of A. Here F inverse of B1 is also the pre-image of set B1 under F. So these are some examples and properties which they have given. Okay, so I have explained you what is domain, range and codomain. What is now? We'll just find it from the given diagram. So we have, one second. Suppose so here we have A and B. A they have given as 2, 3 and 4, and B they have given as A comma B comma C. Now relation is given as, that is relation, that's function is given as 2 comma A, 3 comma B, 4 comma B. So yeah, how it will be mapped? So we have A, in A we have this A and this is B. In A we have 2, 3 and 4. In B we have A, B and C. So 2 is mapped to A, 3 is mapped to B, and 4 is mapped to C. So now what will be domain? Domain are the elements which are present in A. So the domain will be 2, comma 3, comma 4. Then what will be codomain? Codomain will be the elements which are present in B. That will be A, comma B, comma C. Then what will be range? Range of F. So here 4 is mapped to E, not for C, it is mapped to B. 4 is mapped to B. So yeah, a range will be the answers what we have, A and B. The image what we get will be the range. So now moving with the next part, we have types of function. What are the different types of function? We'll discuss now. So yeah, in types of function, we have first one is called one-to-one function. One-to-one function. What is one-to-one function? One-to-one function is also called injective function. Injective function. For here, definition will be a function is said to be one-to-one if every element of domain should have one and only one image in codomain. Then it is called as one-to-one function. For example, every element of domain should have only one image. Then this is example for one-to-one function, where f of 1 is having one image, f of 2 has only one image, and f of 3 is also having only one image. If it has one and only one image, then it is called as injective, or it is called as one-to-one function. Then moving to the next one. Second one is onto function. Second is onto function. On onto, or it is called surjective. Surjective function. Now what is mean by onto or surjective function? Onto or surjective function. So yeah, onto is every element of codomain must have at least one pre-image in domain. At least one means it can have 1, 2, 3 and n number. Okay, codomain. For example, so here so f of a is having 1 and f of a has the pre-image 2. then f of b is having 2, then f of c has 3. So here every element of codomain has one pre-image, but it can also have two pre-image. Then it is called as onto function or surjective. Now, how to prove this one and onto? By using the problems. How do we solve this? By using the problems. This is representation of that. Now, solving. For example, if I take for 1 to 1, prove that the function is 1 to 1. Okay. So, for example, they give you the function f of x equals 3x plus 5 is 1 to 1 1, 1 to 1, or it is injective. So, how to prove? It's very simple. Let x1 comma x2 belongs to f. Let x1 comma x2 belongs to f. Okay, such that you can take f, or if they've given the relation r, you can take it as r. If is a relation from r to r, we can take it as r. Okay, then x1 and x2 belongs to r, then f of x1 will be equal to f of x2. So now what is the formula we have? We have 3x plus 5 equals 3x plus 5. Since we have here 1 and we have here 2, we should write. Now, since 5 is common in both the side, it will get cancelled with the same sign. So what will remain? 3x1 equals 3x2. 3x2. So here what happened? Next step, this 3 and 3 get cancelled. 3 and 3 get cancelled. So it will be x1 will be equal to x2. x1 will be equal to x2. So here we will just prove that it is a function, 1 to 1 function. Okay, we can prove that by two different methods. That is, one is by mapping and second one is without a mapping. We will be doing it. So I'll just show you both the method. So suppose they have given a is 1 comma 2 comma 3 comma 4, and b is a comma b comma c comma d. Then function f is 1 comma b, 2 comma a, 3 comma d, and 4 comma 5, 4 comma c. So f is 1 1. We have to prove it is 1 1. So yeah, we'll just prove it by a diagram. You can prove in both the methods. Okay, anyone whichever you refer, easy you can do it in that. So yeah, it is f of x, here it is a, and this is b. The elements of a are 1, 2, 3, 4. The elements of b are a, b, c, d. So there is a mapping from 1 to a, 2 to b, 3 to c, and 4 to it is here. One second. We'll just map it again. See here. So now we have 1 to b, 1 to b, then 2 to a, 2 to a, then 3 to d, and 4 to c. So here we can write f of 1 equals b, f of 2 equals a, f of 3 equal d, and f of 4 equals c. So every element of domain has only one image. Therefore, it is 1 1. You can write every element of domain has only one image in codomain. Codomain. Therefore, it is a one-to-one function. Therefore, it is one-to-one function. Or it is called injective function. Okay. The other type of question what we may get is, second type we will get. For example, here f from R to R is given by the function f of x equals 3x plus 5 is where all x belongs to R. X belongs to R. Prove it is one to one or injective. So it's a simple problem to prove. Let x1, will take two elements, let x1 equals x2 or x1 comma x2 belongs to R, then f of x1 will be equal to f of x2. So now they've given the function is 3x plus 5 equals 3 equals, so yeah, f of x2 5 equals 3x plus 5. So here it is 1 and here it is 2. So what happens? The same terms will get cancelled both the side. So 3x1 will be equal to 3x2. So again 3 and 3 will get cancelled. We will be left out with x1 equals x2. Therefore, it is f is 1 1. F is 1 to 1. A function f from a to b is not 1 to 1 if there exists an element a1 and a2 with the f of a1 is f and f of a2 where a1 is not equal to a2. So here it says there should be no two elements which are mapped for the same domain. Okay, there should be no two images which will be mapped to same one domain element. Then you have to prove that the function is one to one. It is sufficient to prove if a1 and a2 belongs to a such that f of a1 is equals to f of a2 and a1 is equals to a2. To prove that the function is not f of a 1 to 1, we can just prove a1 in a1 comma a2 is in a, so that f of a1 is equals to f of a2 but a1 is not equal to a2. Then with the a elements a1 a2 an and b elements b1 b2 bn, where m is less than or equal to n, then the number of 1 1, this is important one, the number of 1 1 function from f from a to b is given as n factorial divided by n minus m factorial. To find the number of 1 to 1 function, we should use this formula. To find the number of functions in the function, we have to use n power m formula. Okay, so now next one you have, it is one onto functions. Onto is nothing but it's called surjective. So how do we write that represented? A function f from a to b is called onto or surjective function if every element in b is the image of at least one image in a. That is, for all b belongs to capital B is equals to f of a for some elements of a. Or in other words, the mapping f from a to b is called as onto if every element of b is an image of at least one element in a set a. So we represent this function one to one as this. A function f is not one to one if f from a to b there exists b belongs to b such that f of a doesn't have the element b for some a belongs to capital A. So yeah, what is it as? If x belongs to capital X, there exists y belongs to capital Y such that f of x equals y. This is one way of representing the formula of one to one function. Okay, then it is 1 2 3 5 6 7. So here it is mapped. This is a and this is b. So here this is a function f of x. Then we can write this as 5 equals f of a, f of 1, 5 equals f of 3, then 6 equals f of 2, and 7 equals f of. So every element of a codomain has one pre-image. It can have one and it can have more than one also. It can have one and more than one pre-image. So every element of a codomain has one pre-image. Therefore, it is one function. Okay. So yeah, for example, how to prove this? Let a equals 1 2 3 4. Let a equals 1 2 3 4. B equals a b c d. Then f of a equals 1. It is a 1 comma a 2 comma a 3 comma b 4 comma c and 5 comma a. F is surjective function as every element of B is a image of every element of A. So if it is having an image of elements of B is a image of some elements of A, therefore it is a function. Okay. Then now just defined whether it is 1 1 and not 1 to 1. So yeah, we can say since here beta has no element which is not connected to any element of domain, therefore it is not one to one function. Then yeah, it is onto but not 1 1 because a and d has the same image. It cannot be onto, but every element of codomain has one pre-image. It is onto function. Then here we have every element of domain has one image. So it is 1 1 1 1 and onto. Then every element a has a two pre-image, that is two image, that is beta and so it cannot be 1 1. So now onto every element of codomain has one pre-image. Yes, it has one pre-image. So it is, yeah. Okay. So every element is there. Therefore, it is neither 1 1 nor no onto. 1 to 1 and non onto. Okay. Now, what is mean by bijective? Bijective is if the function is both 1 1 and onto, it is called bijective. What is a bijective? Bijective is a function if it is both 1 1 and onto. It is repeatedly asked a question, what is bijective function? It is 1 1 and onto. If the function is 1 1 and onto, then it is called as bijective function. Or even we can say if the function is injective or surjective, injective and surjective, it is called bijective function. Okay. So now if we will prove it is 1 1 and on 2, so here every element of domain has one image. So it is 1 1, and every element of codomain has one pre-image. Codomain has one pre-image X. Codomain B has a pre-image Y. Codomain C has a pre-image Z. Therefore, it is both 1 1 and on 2, and hence it is a bijective function. Then constant function. What is mean by constant function? Constant function means every element of domain will have one and only one image, then it is called as constant function. Every element of domain has only one image, then it is called as constant function. So f of 1 is k, f of 2 is k, f of 3 is also k, therefore it is called constant. What is identity function? A function f from f to a is said to be identity if every element of a is mapped to itself. So 1 is mapped to 1, 2 is mapped to 2, 3 is mapped to 3. Therefore, f of x is the general formula for identity function. So f of 1 is equals to 1, f of 2 equals to, f of 3 equals 3 is an identity function. Then next one you have into function. What is into function? Into function, a function f from a to b is said to be into function if at least one element of set b is not an image for any element of a set a. So that means there should be an extra element in b which should not have any image, then it is called as into. There should be one one extra element in b in codomain which should have no image, should have no image, then it is called into function. Then many to one function. Many to one function, what is many to one function? So a function f from a to b is said to be many to one if different element of a has the same image in b. Different element of a has minus 1 and 1 is also 1, minus 2 and 2 is also 4. We are taking the square of the number. Okay. So here we are taking a square of the number. Minus 1 square is 1, plus 1 square is also 1. Minus 2 square is 4, then plus 2 square is also 4. So here the function is f of x square. F of x is equals to x square is the function. For example for many to one function. Okay. Then moving on with the next one. Next one is called composite function. What is a composite function? Let A, B, and C be any three in a non-empty set. Let F from A to B and G from B to C be any two functions. The composite function is GOF. A from A to C. A to C is defined as GOF of A, that is F of G of F of A. GOF is nothing but G of F of A. So here we can write composite function is nothing but G of X. That will be GOF, GOF. We can write GOF of X. So yeah, we have two functions G of X and F of X. So GOF will be G of this, of means bracket F of X. So GOF of X can be written as G of F of X. Then we have another one called fog of X. So that will be F of this, of means bracket G of X. So these are the two composite functions. Okay. So there is a function from A to B and from B to C, and A is connected to C is called as GOF. Then here they've given some example here. So here GOF is shown as, see how to find here. If A is 1 2 3, if A is 1 2 3, B is AB, and C is 5 6 7. Function is 1 comma A. We'll just solve this. We'll find the answer here. So yeah, it is, they've given A, B, and C. So A is 1, 2, 3. B is A, B. C is 5, 6, 7. Then we have mapping from A to, this is F function, this is G function. So in F, 1 to A, then 2 to A, then 3 to B. Then G is A to 5, then B to 7. Now find a GOF of X. So now what are the values we have in X? This will be X here. These are the elements of X, 1, 2, and 3. Okay. So we'll find for 1, 2, and 3. So if X is equals to 1, so it will be G of means bracket F of 1. That will be G of F of 1. When F value is 1, what is the answer we got? We got B. So it will be, sorry, we got A. That will be in place of F of A. Or before we could do this, I will do one more step for you, and then it will be easy for you to remember or understand. We'll write that part and then we will solve this. It will be easy for us to solve the problem. Okay. So here, what is that? We can write here F of 1 equals A, then F of 2 equals A, then F of 3 equals B. Then yeah, G of A equals 5, G of B equals 7. Now we'll write GOF, they have to find GOF of X. So GOF means nothing but it is G bracket F of X. So now if I take X value as 1, that is yeah, the first bracket, first circle or oval, X is equals to 1, then G of F of 1. So what is F of 1 value we have? It is A. So G of A. Now what is G of A we have? It is 5. Following? Again, next one. We have second X is 2. X is 2. So G of F of 2. So what is the value of G of 2? It is A. So it will be G of A. Now what is the value of G of A? The value of G of A is 5. Then X is 3. So G of F of 3 equals G of, what is F of 3 value? B. Then what is F of B? F of B is 7. So here GOF of X equals, if X is 1, it is always X comma Y. X is 1, the answer we got is 5. Then if X is 2, we got the answer as 5. If X is 3, we got the answer as 7. So this is how we find the GOF function. Okay. Then you have other one. Consider the function f and g defined by the function f is equals to x cube and g of x is equals to x square plus 1. Find GOF and fog and GOF. When verify fog and GOF for are equal. Okay, and just like let us do this one. It's an important one. How to find the fog and GOF. So they have given here. It is f of x equals x cube. G of x is equal to x square plus 1. X square plus 1. So now they're asking you to find the fog of x. So yeah, f of g of x. Okay. So what we are going to do is, in place of g of x, what is the value we have? So that will be f of, in place of g of x, you'll write the value what we have here. So it will be x square my plus 1. Now it is in the form of formula f of x. So we'll write the formula of f of x. F of x equals x cube. Call this as equation 1. Now compare the f of x values. We have x here x, and here we have x square plus 1. So x value is changing to x square plus 1. Now substitute in x in equation 1. We get, that is, we get in place of x, we'll write it the value as x cube. You call this, you will be substituting x value in here. So today x square plus 1 whole cube. X square plus 1 whole cube will be the answer for fog. Hope you understood this. Yeah, moving with the next one we have. Next one is, we have to find the answer for GOF. GOF of x. GOF of x is g of f of x. That will be g of, what is the formula for f of x we have? It is x cube. So we'll write it as x cube. Now we have it as g of x. We'll write the formula for g of x. G of x equals x square plus 1. We'll call this as equation 2. Now compare this both. Compare this both. G of x, here we have x and here we have x cube. So here x is changing to x cube. Now what you'll do? You'll substitute. We'll substitute x value in equation 2. So wherever we have a 2 x, we'll write it as x cube. So today x cube whole square. In place of x, I am writing x cube. X cube whole square plus 1. That will be nothing but x to the power of 3 2s are 6 plus 1. So this will be your answer, second answer. We'll call this as 4. So yeah, comparing both first one and second one. First one you got x cube and second one you got x 6 plus 1. So therefore fog is not equal to GOF. The answers are not equal to each other. Okay. So now moving with the next one, we have some note properties of this. So here the composite function is not a commutative. It is not a commutative. Okay. Fog is not equal to GOF. So it is not a commutative property. Therefore, composite function is a associative. It can be associative. F of g of h can be equal to f of g of h. Associative property hold good for composite function, but commutative property does not hold good. If f from a to b and g from b to c, then one to one function are one to one function. When then GOF is also one to one. If f from a to b and g from b to c is one onto function, then GOF is also onto function. If a from b, if f from a to b and g from b to c is bijective, then GOF is also bijective. That means if the function are one to one, onto and bijective, the composite function will also be one to one, onto and bijective. Then moving on with the inverse. Now what is mean by inverse? Inverse is nothing but if x is equals to x from a to b, x from a to b, x from a to b is a bijective function from a to b. Then there exists a function g from b to a such that g of b is equals to a, and g is the inverse of the function a, which is denoted as f dash, or g is equals to f inverse, which is, it is also known as invertible function. So what is it? A function from a to b is bijective. If which from a to b, it should be 1 1 and on 2. If it is 1 1 and on 2, then there exists a function g from b to a. It is a reverse function from b to a, such that g of b is equals to a. There g is called as inverse of a, and it is represented as f inverse or g is equals to f inverse. G is equals to f inverse, and it is also called as invertible. If it is inverse, it is also called invertible. Okay, this is only called as invertible if you prove this. So how do we prove this? We'll just do this problem and check out. So here we have already found for Goff and Fogg. To prove it is a inverse, what we need to prove, we can even prove the function. If it is Fogg and Goff, then it is called as invertible function. We'll do this problem. So here we will find this function. Consider the function f from r to r, f from r to r, where f of x equals 2x plus 5, and g of r to r is another function from g of x equals 1 by 2 into x minus 5. So if you want to prove g is inverse of f, what you should prove? We can prove it as Fogg and Goff satisfies. So yeah, it is Fogg of x or Goff of x. Anyone you can do. So it is f of g of x. So now f of, what is the g of x formula? We have half into x minus 5. So we are just representing the value of g of x. Then write the formula. F of x is 2x plus 5. Call this as equation 1. Now compare x value with both the f of x functions. So x is changing to 1 by 2 x minus 5. Now substitute this value in equation 1. We get 2 into, in place of x we will write this value, that will be 1 by 2 x minus 5, and this plus 5 as it is. Then this 2 and 2 get cancelled. If it is cancelling, what we get? We get x minus 5 plus 5. So minus 5 and plus 5 will get cancelled. We get the answer as x. So yeah, Goff, Fogg of x equals x. F of x. What is f of x? We have g of f of x is 2x plus 5. So write down the formula of g of x. G of x is 1 by 2 x minus 5. Call this as equation 2. So now compare x value. We have x equals 2x plus 5. Now substitute this in equation 2. We get 1 by 2. Only in place of x we should write that answer. That will be 2x plus 5 and minus 5. So plus 5 and minus 5 will get cancelled. It will be 1 by 2 into 2x. 2 and 2 will get cancelled. The answer is x. So Goff of f of x is also x. So here Fogg is also x, Goff is also x from 1 and 2. From 1 we can call this as, we'll call it 4. and for fog we'll call it as 3. We can write from 3 and 4. 3 and 4. We got what? We got fog of x is also x, and gof of x, gof of x is also x. Okay. Therefore, f and g are inverse to each other. You can write f is in f and g. F and g are inverse of each other. Of each other. So yeah, moving with the next one we have if a is a function from a to b is invertible, then it has a unique inverse. Further, if f of a is equal to b, then f inverse of b is equals to a. For example, if I write if I write here f of 2 is equals to 5, then f inverse of 5 will be equal to 2. Okay, that will be inverse. Then if a function a to b is invertible if and only if it is bijective. We can invertible only when it is bijective. Okay, or it is inverse we can find only when it is bijective. Then if f is a to b and g is b to c are invertible if of are invertible functions, and g of f inverse is equals to f inverse of g of f. F inverse of g of f. 2, 3, 4. B is 1, 2, 3, 4, 5 and 6. 5 and 6. How many functions are there from A to B? So, what we have to do is, how many Cartesian number 1, 2, 3, 4? There are 4 elements that we can call it as M. Then B has 1, 2, 3, 4, 5, 6. 6 element that is called as N. So, we have learned the formulas. What will be there? The first one, number of functions from A to B equals n to the power of m. That will be 6 to the power of 4. That means you multiply 6 how many times? 6 to the power of 4 means it is 6 into 6 into 6 into 6. So if you multiply you get 1296. Then second one it is given. What they asking, how many of these are 1 1? Number of 1 to 1 function. Number of 1 to 1 function equals formula n factorial divided by n minus m factorial. What is n? N we have 6 factorial divided by 6 minus 4 factorial. So that will be 6 factorial divided by 2 factorial. So yeah, what will be the answer? That will be 6 into 5 into 4 into 3 into 2 factorial divided by 2 factorial. Since I have 2 down, so I'll stop till 2. 2 and 2 will get cancelled. So it will be 6 5s are 30, 4 3s are 12, 12 3s are 36, and then 0. So how many one-to-one function? We have 360 one-to-one function. Then moving with the next question. It is if A and B are 1, 2, 3, 4, defined a function as, if possible, such that f is 1, 1, 1 to 1 and on to. So we have to do it by ourselves. We have to find the answer for ourselves. So yeah. So here, if it is A and B are same, A and B are same 1, 2, 3, 4. 1, 2, 3, 4. First one you have to prove it is 1, 1 and on 2, that is bijective. Means every element of A should have one image, and every element of codomain should have one pre-image. So it is called as 1, 1 and on 2. That is bijective. So next one, second one, it is saying to prove it is neither 1, 1 nor on 2. So we have 1, 2, 3, 4. You have 1, 2, 3, 4. So I'll take one element which is not having image. The other elements are having image. So yeah, one has no image. It is not one to one. 1 1. No? And then 4 has no pre-image. 4 has no pre-image. Pre-image. It is not onto. It is not onto. So like this you should give examples. Okay. It is 1 1 and not onto means it should be 1 1. It should be 1 1. But it should not be onto. So 5 has no pre-image. Has no pre-image. It is not onto. It is not onto. Then F is 1 1 but not onto. F is onto but not 1 1. F is onto but not 1 1. That will be 1, 2, 3, 4. 1, 2, 3, 4. It is 1 1 but not onto. So that means every element of codomain will have one pre-image, but there is one extra element 5 which is having no image in the codomain. In the 5 is having no image in the codomain. Therefore, it is called as it is onto but not a 1 1. It is onto but it is not 1 1. So this is how you'll give the example if they give you ask you to find the write down. Okay. So this we have already done. So moving with the important question here, find the bijective function. They may ask you find the function f from R to R is defined by f of x. F of x equals 2x plus 5. 2x plus 5. Prove it is 1 1 and on to. First type they can ask you. Prove it is 1 1 to 1 and onto, or they may ask you second type, it is bijective, or third type they can ask, it is injective and surjective, injective and surjective, surjective, or they may ask you find inverse or invertible. So for all this type of question, only one solution we have. Okay, what will be the solution? It's a very important question. So how to find this? It is 1 1 on 2, or it is bijective, or injective, or surjective, or inverse and invertible. It's very simple to see. Yeah, let x1 and x2 belongs to R. Then f of x1 will be equal to f of x2. Then function is 2x plus 5 equals 2x plus 5. So here we have 1 and here we have 2. So then like terms will get cancelled both the side. So it will be left out with 2x1 will be equal to 2x2. Then 2 and 2 get cancelled. It is x1, x1 will be equal to x2. Therefore it is 1 1. Therefore f is 1 to 1. Then how to prove it is a onto? To prove onto, we should write let x belongs to R, there exists y belongs to R such that f of x equals y. So now we have to take that formula f of x, what we have, it is 2x plus 5 equals y. So now this is in the form of y formula, we have to convert in the form of x formula. Okay, so first we will send this 5 other side, it will become 2x equals y minus 5. So I want to convert it into formula of x, so I'll keep x as it is. So x equals y minus 5 divided by 2. So this is called as, if you find till here it is, therefore we can say f is 1 2. F is onto. If it is onto and 1 1 and 1 1 and onto, it is f is bijective. F is bijective. F is invertible. F is invertible. F inverse of F inverse of x, F inverse of y will be equal to y plus minus 5 divided by 2. So this is the inverse of the function and therefore f is invertible. Okay, this is how we find the 1 1 and onto functions. So here they have given few examples to find 1 1 and onto. Just go through with all this and try to prove them. Okay, here you can see one more example I'll just discuss. So here you have it is not 1 1, so we'll take x1 is not equal to x2. Then x1 equals 3 into 1 square plus 2 is equals to 5. 3 ones are 3 plus 2 is equals to 5. Then if it is minus 1, then 3 into minus 1 whole square plus 2 is also 5. Here what we can see here is f of x1 is equals to f of x2, but x1 is not equal to x2, therefore it is not 1 to 1. Okay, so similarly you have many problems based on that, fog of inverse and other things, how to find them, just go through with that. Okay, so I will do this problem for you. So yeah, I'll just solve this for you, that is for fog and cough. If they give you this type, how to solve them? We'll do it first method. We will try with the first method there. That is, we'll be finding n 1 1 and on 2. So let x1 comma x2 belongs to R such that f of x1 will be equal to f of x2. So now what is x1? F of x, we have 4x plus 3 will be equal to 4x plus 3. So now here it is 1 and here it is 2. So what happens? X and x will get cancelled. So left out is 4x1 will be equal to 4x2. Then 4 and 4 will get cancelled. We have x1 equals x2. Therefore f is 1 1. Therefore f is 1 1. F is 1 1. 1 to 1. 1 to 1. F is 1 to 1. Now we have to prove it is onto. So how to prove it is onto? So yeah, to prove onto, let x belongs to R. X belongs to R. There exist y belongs to R such that f of x equals y. Now what is f of x? We have 4x plus 3 equals y. Now we have to convert the formula in terms of x. So I want only x. Remaining terms I'll be sending other side really. X equals y minus 3 plus 3 goes other side minus 3. Multiplication goes other side become division. So x equals y minus 3 divided by 4. Therefore f is onto. So if it is both 1 1 and onto, it is invertible. It is f is invertible or it is invertible. Okay. So this is one way of finding it. The second way we can find even by using the Goff and Fogg function. Since the f is 1 1 and onto, it is invertible. Okay, f is invertible. Then we have other method also where we can use the other method is by finding Fogg and Goff. But here this is they have not given Goff, we cannot do for Fogg and Goff. They have given only one function, so we'll be finding 1 1 and onto to find it is a invertible. If they have given f of x and g of x, then we will be finding Fogg and Goff method. Okay. Then moving on with the next one, you have g is g. So here g is r to r. G is r to r, where g of x is 2x plus 4. We have to find the inverse of g. First, to find inverse of g, what we should do? We have to find it is 1 1. Okay. So let x belongs to r. There exist y belongs to r such that f of x equals y. Here we have g, so we'll take g of x equal y. So now g of x equals y means 2x plus 4 equals y. So I want only x. So 2x plus 4 goes other side become minus 4. Then I want only x. X will be x equals y minus 4 divided by 2. So now what is the inverse of this? That is nothing but g inverse of y. This is only g inverse of y. So we have found the inverse. Okay. Same way you will be finding the 1 1 and onto and the find the functions for inverse. Okay. Then next one you have is What is the inverse and what is this? Okay. We'll be finding fog and goff for these two problems. Then next one you have is is we have to find fog and goff. They've given the function. We are finding the fog and goff values. Okay. So here they've given f of x is x square plus 3x plus 1 and g of x is 2x minus 3. So now we have to find a fog and goff. So fog of x means it is what? F of means bracket g of x. Now what is the value of g of x? It is f of 2x minus 3. Now write the formula of f of x is x square plus 3x plus 1. Now compare the x value with this x value. So x will become 2x minus 3. Now call this as equation 1. Substitute x value in equation 1, we get 2x minus 3 and that will be whole square plus 3 into we have 2x minus 3 into plus 1. So what we are doing, we are just substituting the value of x. In place of x we are substituting the value as 2x minus 3. Now it is in the form of 2x minus 3 whole square means write the formula a square plus b square minus 2ab. So the formula we have is a minus b whole square, a minus b whole square will be a square minus plus b square minus 2ab. So here a is 2x, so it will become 2x square, 2x whole square plus 3 square minus 2 into 2x into b is 3. Then we have plus, remove the bracket, 3 into 2 is 6x minus, plus into minus is minus, 3 3s are 9 plus 1. So, sorry, I should write here. It is plus 6x minus 9 plus 1. So, yeah. So, now next is simplifying this, what we get? We get that is 2 2s are 4 x square plus 3 3s are 9 minus 2 2s are 4, 4 3s are 12, 2 2s are 4, 4 3s are 12, 12x plus 6x minus 9 plus 1. So what happens? Minus 9 and plus 9 get cancelled. So the answer is 4x square plus 6x plus 1. What we found this? This is fog of x. Okay. The same way we'll be finding for goff. What you should find for goff? Next one is g of g of f of f of x. So that will be g of bracket f of x. So now what is the formula for f of x we have? It is x square plus 3x plus 1. Now write the formula of g of x. G of x is 2x minus 3. Call this as equation 2. Now compare x value with this g of x. So now your x will become, x value will change to x square plus 3x plus 1. So now that will be, substitute x value in equation 2. So that will become 2 as it is. So in place of x, we'll write the answer what we got, x square plus 3, substituting x value, okay, plus 1, then minus 3 as it is. Remove the bracket, it will be 2 into x square, 2x square plus 2 3s are 6 x, multiplying 2 into 3 6x plus 2 into 1 is 2 minus 3. So the answer will be 2x square plus 6x plus 2 minus 3 is minus 1. So this is your GOF of x. This is how you find fog and GOF. Okay. So same way you can find for this also. We'll move on with the next one. Then you have fog and GOF again. You just simplify these problems. Okay. This all you can solve by yourself. Now next one you have here they've given f of x is a b c. F of a, f is a comma b, b comma a, c comma a. So a comma b, then b comma c, then c comma c. Okay. Now we have to find f dash of f inverse. What will be f inverse? How to find this? I'll show you. So now they have given f of x is what they've given as a comma b, then b comma a, then c comma c. Okay. Now we have to find f inverse of x. So f inverse is nothing but you have to inverse, b will become a, that will be b comma comma a comma b, we should reverse it, a comma b, then c comma c. Okay. So we'll just write it in a reverse order. If you want you can draw. So it will become b a c, then b comma a comma b and c. So this is a inverse, this is function and inverse function where this is a and this is b. Okay. Now how to find for f square, if they give you how to find f square, so I'll show you for f square. So now f square is f of of x. So here it will be f of f. What are the values of x we have here? What are the values of x? X is a b c. They've given x is a b c. Okay. Now take it as a, first one. So it will be f of means bracket, f of a, then f of f of a is what? f of a will be b, answer is b. So f of a is b. Then what is f of b? What is f of b? This is a function, f of b is a. So the answer will be a. Then f of second one, f of b. So that will be f of f of f of b. So what is your b value? B is a. So this will be f of a. Then what is f of a? A value is b. So we just write the values here. F of a is b. Then f of c. F of c will be f of bracket f of c. F of c. So now what is f of c? C. F of c is c itself. So f of c. Then in this place we are writing c value. Then what is f of c? F of c is c. That's it. This is a f square. Okay. Same way you will be doing for f cube and f to the power of 4. Just go through with that. So the last we will do this problem. We have last one is last problem is consider the function is f of x. It's an important question. So yeah, f of x will be x square minus plus 3x plus 1. So now we have to find f square and f square of 1. So yeah, f square of x means f of f x, that will be f of bracket f of x is x square, that is f of x. Now f of x is what value we have? X square plus 3x plus 1. Now compare f of x formula. We have f of x formula is x square plus 3x plus 1. So now call this as equation 1. Okay, call this as equation 1. And now compare the x value what we got. The x is here, x, and here x value is x square plus 3x plus 1. So here x will change to x square plus 3x plus 1. Okay, now substitute this x value in equation 1. So we get, if you substitute in equation 1, that will be f of x will be equal to, okay, now x, wherever we have x, will write this value, that will be x square plus 3x plus 1 whole square. Okay, then we have plus 3x, that will be plus 3, x is this x square plus 3x plus 1 and then it is plus 1 again, then it is plus 1 plus 1. So this is a formula. What is the formula we have? We have a formula a plus b plus c whole square is equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So substituting that value, this will be a, this will be b, and this will be c. So we get expanding this, we get x square of whole square plus 3x whole square plus 1 whole square plus 2 into a is x square, b is 3x, then plus 2 into bx will be b is 3x and c is 1, then plus 2 into c is 1 and a is x square. Then expand this. If expand this, what we get? So we get, yeah, it will be plus 3 into x square is 3x square plus 3 3s are 9, 3 3s are 9x plus 3 into 1 is 3 plus 1. So here the answer will be x to the power of 4, 2 twos are 4, multiplying the power, plus 3 threes are 9, x square, plus 1 ones are 1, plus 2 threes are 6, x square into x is x cube, then 2 threes are 6 into x, 6 into x, plus then 2 into x square will be 2x square, 2x square, then plus plus 3x square plus 9x plus 4. 3 plus 1 will be 4. 3 plus 1 is 4. So now if you simplify this, we get x power 4 plus, we can take a cube 6, arrange in a power, x, 6x plus 9x, it will be 15x plus 15x, then here it is 4 and here it is 1, so it is 4 plus 1 will be 5. So this is your f square. So they're asking you to find f square of x. They're asking you to find f square of 1. So wherever you have x, we'll write it as 1. So it will be 1 power 4 plus 6 into 1 cube plus 14 into 1 square plus 15 into 1 plus 5. So the answer is 1 plus 6 plus 14, 14 plus 15 plus 5. So now 15 plus 5 is 20, 14 plus 6 is 20, 20 plus 20 is 40, 40 plus 1 will be 41. So f square of 1 is 41. So this is a very important question. Okay, so practice and learn the problem. If you are having any doubt, you can write in the comment box and you can share it with me so that I will sort out your problems. Okay, so now in the this is that function we have completed the unit. So in the coming class I will be discussing about, I'll be, you have this problems are given, exercise problems. I want you people to solve this 2.46 and send me the answers, or you can just check out. If you're not able to do any problem from this exercise, you can send me in the comment box. I will try to solve for you. Okay. So you have this many 18 problems are given. Try to solve those problems. Okay. In the next class, we'll be learning about the sequence and summation, and then we'll go for matrix. Okay. Okay, students. Thank you. Thank you for watching.